I'm going to show you how you can code a binary search tree. Now, before we actually start, if I have my tree drawing, it looks something like this. Okay, and each of these circles are called nodes. So we're going to have a class of node, and inside of that class we're going to have a left and also a right. Okay, because this is the left, this is the right, and we're going to have the data. So this is our custom class we're trying to make of node. Each node has a left which points to the next node, and each node has a right which points to the next node. And if it doesn't point to any of the other nodes, okay, then it's gonna have null there in the left and the right. So yeah, that's basically the structure of the node. So we're gonna have a class of node of right, and then I'm gonna make everything public inside of there, int data, and just like in the linked list, we're gonna use a pointer for the node, the addresses. Okay, and we're not gonna call this next like we did in a linked list. We're going to call this left, and we're gonna call int right. Perfect. Now once we actually done that, I want you to create a constructor, and inside of this constructor we want to have data. Alright, so you pass in the data and you're gonna make it equal to d. Once that's done, then you're gonna say left is equal to right is equal to null, basically initializing left and right to null. Okay, that's pretty much our node class. But here's the thing, we want to implement an abstract we want to implement some abstraction. So what that means is that we want all our functions that act on that tree, and also all of the class of the tree, as well as the functions that act upon that tree, to be in one class, so that we can just come here and we can just access, like, say tree dot insert. Otherwise we're gonna have to make a node class, and then we're gonna say maybe node and n1, and after that we're gonna say n1 dot left is equal to n2, stuff like that. So we don't want really that to happen. Now for that reason we're going to create another class. Okay, and we're going to call this class tree. Alright, now what I'm going to do is I'm going to paste all of the node class, the entire node class, inside of the tree class. Don't forget your semicolons. And once I'm done with that, I'm going to say public. Before public, I'm going to create the root. Okay, I'm going to create a node, and I'm going to call it root. Okay, basically I'm creating the root node. You know what the root node is, right? This node, the topmost node, is called the root node. So why are we creating the root node? Because if root is equal to null, we know that the tree is empty. So that's why. So then what I'm going to say, I'm going to create the constructor. I'm going to say int data. Actually no, you don't really need to create the data, I think. Yeah, sure. Okay, so inside of this tree I'm gonna do something. I'm gonna set my root to null. Let's just do that, meaning that the tree is empty. Okay, so pretty much that is it for the code of this tree, and next we're going to start to write the functions.